I would suggest doing this in pencil just because people have, made some mistakes and then it's really hard to kind of go through stuff because you guys we're gonna do one together and then the rest of them you're gonna do on your own. So we just want to make sure that you've got stuff down, that you're watching what we're doing and understand where we're getting information from. And you guys are really good about asking questions, so just make sure you do that. Okay, let's kind of back up from yesterday. Why did we know to put capital M on the top? Okay, so what's dominant? Yep, so the purple kernels are dominant. How did we know that it was going to be capital M? What is?
Purple kernel.
And then what about the little m?
The yellow kernels.
The yellow kernels are what? Yeah, they're homozygous recessive. What are we doing? Like, what is this scenario? Like, what's happening?
The mutations.
We're not doing mutations with this one. We're breeding. Yeah. This was kind of the thing that I realized second hour, that they didn't quite get what we were doing with corn. So I'm taking a corn plant and another corn plant, right? Because I need two corn plants to make another corn plant. So there's a purple corn, there's a plant with purple kernels, purple corn, and then a plant that has yellow kernels. And I'm breeding them, crossbreeding them, so that I am going to make a new kind of corn, possibly. All right, so what is the thing that these genes are controlling? Kind of said it already. The color of?
The corn.
Yeah, the color of the kernels. Because it's not the color of the leaves or anything like that. It's specifically the kernels.
Like popcorn has leaves?
No. Yeah, corn has leaves. The corn plant. Yeah. Well, and then like the stalk itself has like the leaves, and then there's the husk. Yeah. And like this is popping corn is like that too. Like Zea mays can be used for popping corn or for just regular corn on the cob corn. Okay, so then what are the variations? Okay, is that a variation of the gene?
No.
That's a variation of the color. What's the variation of the gene?
M.
Okay.
Capital M, capital M.
Okay, and?
Lowercase m, lowercase m.
And?
Top of the M, lowercase m.
Mm-hmm. Those are all of the variations that exist.
Stop, bro.
If I have capital M, what's going to be the phenotype?
Oh,
Purple.
Purple. Remember, what does phenotype mean? It's just a physical trait. What does it look like? This is the gene. Capital M is going to be purple. Whoops, not purple. Purple.
Purple.
What's going to be lowercase m? Yellow, yeah. What's going to be capital M, lowercase m? Why? Oh, it's going to be purple and yellow?
No.
Just purple. Why?
Said so.
It's a dominant gene. That means if there is even one of the genes, it's going to be that dominant trait. This one, it's obvious. There's only yellow option in the genotype. This one, because it's got both. That's why we write it with a capital letter, because then it's easier to see which one is which. Again, the words are the phenotypes. So the words are the phenotypes that describes the trait. The genotype is just the letters. Okay. So now, let's go ahead and fill in the squares. Squares. So for this, we are breeding the offspring. And it says we're breeding those heterogeneous offspring. Even without looking up there, if it's heterogeneous, I know that it's going to be
Heterozygous.
thank you, heterozygous. I know that they're going to be different alleles. All right. So I am taking one of these offspring and one of these offspring. Right? So that's what an F1 cross is. Not like F1 racing. So I'm going to just take that, capital M. All right. Go ahead, do this, answer these questions. Mr. Burns and I are going to come around and just check how you're doing. Okay.
Here's the information for completing that first part. So once we have identified the parents here and here, we fill in the Punnett square with the alleles from each parent. So we bring down the capital M's and we bring across the lowercase m's. This part right here shows you how to estimate percentages. Each box represents 25% of the possibilities. Then we can use that to figure out the probability of any one kind of offspring. So here's the genotype of the offspring. They're all M, capital M, lowercase m. And that's 100% of those are that genotype. The phenotype is what do they look like. To figure that out, we kind of got to go back up to the top here where we kind of organized it and figured out what each allele will color, what color each allele will create. And in this case, all of the offspring will look purple. It's 100% of them. We also can use another word to describe them because though they're all purple, they're carrying a lowercase m. So these are all carriers for the yellow allele.
Perfect. You guys are doing a great job.
So that is where we were, and then we moved on down to introduce this next question, where we have heterozygous parents. So now see if you can figure this out and fill out the probability, the percentages, the chance of inheritance for each.